Hey, did you ever notice that the root word of function is fun? Yeah, me too. So, with what we've covered so far, there's certain things that you need to remember, and I would suggest having a little 3x5 card or something like this, where you have the definitions of sine, cosine, and tangent using SOHCAHTOA or Oscar had a heap of apples, and then the reciprocal identities, so you just flip all those fractions. Oops, this one was supposed to say cotangent. And then a smart trig class, that tells you when the functions are positive in different quadrants. And then quite often we use a 30, 60, 90 triangle and a 45, 45, 90 triangle. Now on to section 1.4. So actually we start with these identities right here, that cosecant is the reciprocal of sine's fraction, secant is the reciprocal for cosine, and cotangent is the reciprocal for tangent. Those are called the reciprocal identities. So cosecant is equal to the reciprocal of sine. But this is a faster way to say it compared to this line right there. But they mean the same thing. And secant is equal to 1 over cosine. And cotangent is equal to 1 divided by tangent. Oh, let's make this one a little more interesting. Suppose that sine equals 11 divided by the square root of 5. Then find cosecant. Well, you might think it's just as easy as, okay, cosecant is the reciprocal, so the reciprocal would be the square root of 5 on top and the 11 on the bottom. Except I was looking at the homework online and there's one similar to this. And it turns out that this is impossible. Why is this impossible? Well, sine is opposite over hypotenuse. Oscar had opposite over hypotenuse. So this will be the 90 degree. Across from that is the hypotenuse, so this is square root of 5. I forgot to write my theta. And this right next to the theta is going to be the adjacent. Going across from it is the opposite, so this is an 11. Now why is this situation impossible? Well, this is 90 degrees, which means this has to be smaller than 90 degrees. And if this is smaller than 90 degrees, it means this is a smaller side than this. Well, the square root of 5, the square root of 5, oh, I hate those crazy lines. That's why I use my deck of cards right here to prop it up to get rid of that glare, is a 2.236. So this side is 2.236. So this side, there's no way that can equal 11. It has to be something smaller than 2.236. So this 11 is not possible. It's too big. So in fact, sine of theta always has to be less than or equal to 1. It can't go beyond 1 when you're looking at its fraction, because this has to be smaller number divided by a bigger number, and when you have a smaller number divided by a bigger number, the result is always going to be less than or equal to 1. Okay, now on to example number 2 that does have a solution. So let's go with cotangent of theta is equal to -3/5. Then find tangent of theta. So these two are reciprocals of each other, so that means that tangent of theta would be the reciprocal 5/3. And with the negative, you can just leave it in front. Let's go through some fast ones. How about sine of theta equals 1? Then find cosecant of theta. So that means that cosecant is equal to 1 divided by whatever sine equals. So that means it's 1 divided by 1, so it equals 1. What about if cosine equals 0? Then find secant of theta. So secant of theta is the reciprocal of cosine, so it's 1 divided by whatever cosine equals. In this case, it would be 1 divided by 0. And 1 divided by 0 is undefined, or in other words, this does not exist. So division by 0 is not possible. This, cosine equals 0, yes, that's possible. Because, if I can get rid of the glare, if you take cosine of 90 degrees, it equals 0. So even though this original one is possible, when you divide by 0, that does not exist. Okay, there's other ratios, other identities. Like for example, tangent of theta is equal to sine divided by cosine. And cotangent is the reciprocal of that, so it's cosine divided by sine. So why is it that tangent is equal to sine over cosine? So instead of using the words opposite and adjacent and hypotenuse, I'm going to use x for this side and y for this side and r for this side. So what does tangent equal? Tangent of theta is equal to its opposite over adjacent, so it's y over x. That's what this side equals. Then what about this side? So sine divided by cosine. Let's see, so sine is opposite over hypotenuse, so that's y over r. Cosine. Cosine is adjacent over hypotenuse, so that's x over r. And then to simplify this compound fraction, simply multiply on the top by r, multiply on the bottom by r, and it just so happens that all of those r's cancel out, and what's left is y over x, which is the same thing as tangent. So sine divided by cosine is equal to tangent. All right, on to example number 5. Oh, sorry, I didn't know that was off the screen. Sine of theta is equal to 4 over 7. Then find tangent of theta. and cosine of theta. So one way to do this problem is you draw a right triangle. Sine is opposite over hypotenuse. So the opposite side would be 4, and the bigger side, in fact the biggest side, would be 7, hypotenuse. And then we could solve for x by doing the Pythagorean Theorem. X squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. And then subtract 16 from both sides. So x squared is equal to, that would be 33. And then x is equal to the square root of 33. And the square root of 33 can't be simplified anymore, so it stays like that. All right, then cosine. So definition of cosine is it's adjacent over hypotenuse. So that will be the square root of 33 divided by 7. And finally for this one, tangent is equal to sine of theta divided by cosine of theta. So sine was given, that's 4 over 7. And cosine is the square root of 33 over 7. Now the last time I had this, I multiplied the top and the bottom by the same thing, and I could do that here. Another way to do it is when you divide fractions, you leave the numerator alone, change it to multiplication, and then use the reciprocal of the denominator. And you get the same thing as if you had multiplied by 7 and multiplied by 7. Two different ways to do it. So these 7's cancel, and then it leaves 4 divided by the square root of 33. Now you could actually leave the answer like that if you were asked to rationalize the denominator, which is not something I personally insist on, but some people do. Then you would multiply the top and the bottom by the square root of 33. On the bottom, you'd have the square root of 33 times the square root of 33, so that's just 33. And on the top, there would be 4 radical 33. So if somebody asked you to rationalize it, this would be the answer. If you were turning it into me, you could have been done right here. Well, now on to 3 very important identities called the Pythagorean identities. So these come from the Pythagorean Theorem. One of them goes like this: sine squared of theta plus cosine squared of theta is always equal to 1. Now this notation, this is the way that we write it, but sine, when we write it like this, it literally means take sine of theta and square the whole thing. So for example, on the calculator, let's pick an angle like 22. So if you find sine of 22, and then you could just hit the squared button, so it equals a 0.14. So you could do it that way in 2 different steps: sine of 22 and then square the whole thing. Yet another way you could do it is put it in parentheses and say sine of 22, put 2 parentheses, so parentheses around the whole thing, and then square it. And it still equals 0.14. Or the fastest way to type it on the calculator is you put sine of 22, you close the parentheses so that that is the sine function, and then you square it. And it still equals the 0.14. So anyway, what this theorem is saying is if you take sine of 22, square it, plus cosine of 22, square it, you'll get a 1. And it doesn't matter if I use 22 or 97. As long as you use the same thing, 97, it's always going to equal 1. So that's one of the identities. There's two more. There's also 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So which example is this? Number 6. So for example, number 6, suppose sine of theta is equal to 1/5 in quadrant 2. Find cosine of theta. So for this, I'm going to use this identity right here. Sine squared plus cosine squared equals 1. So use sine squared plus cosine squared is equal to 1. Now in place of this sign, put the fraction 1/5. It's still going to have to be squared. So you replace the sine of theta with 1/5, and then it still has to be squared. And then plus cosine squared, and it still equals 1. When you square this fraction, square the top as 1, square the bottom as 25. And then we're almost done with it. The next thing to do is subtract 1/25 from both sides. So these will cancel, leaving just cosine squared equals. And then a 1 can be rewritten as 25 over 25. So the right side really has 25 over 25 minus 1 over 25 is 24 over 25. Now to get rid of the square, take the square root of both sides. So we'll have cosine of theta equals, and when you take the square root of both sides, put plus minus. And when you take the square root of the fraction, you could just take the square root of each one individually. And I'm going to need to finish it right here. So cosine of theta equals, now I need to decide, is it supposed to be positive or negative? A smart trig class says that in quadrant 2, sine is supposed to be positive, cosine is supposed to be negative. And then with this fraction, I could take the square root of 25 is 5. And for a 24, that could be factored as 4 times 6. You could take the square root of 4 is 2. And square root of 6 can't be simplified, so it has to stay as the square root of 6. And that is done. You're right, we should do one more example. Since we came all this way. What is it, example number 7? Suppose that secant of theta is equal to 1, and the angle is in quadrant 1. So this little symbol right there means the same thing as in. Quadrant 1 is in, excuse me, I was saying it backwards. Theta is in quadrant 1. Then find sine of theta and cosine of theta. Well, secant is equal to 1 over cosine. Or another way to look at that is you could do the reciprocal of each side. So make this side secant over 1, and then invert this fraction so the left side becomes 1 over secant. And that works as long as you do the reciprocal on the other side, and the right side will become cosine over 1 or just cosine. So that means that cosine of theta is equal to 1 divided by whatever secant is. And in this case, secant is equal to 1. And because the direction said it's in quadrant 1, that means that all the trig functions are positive, so cosine is equal to a positive 1. And for the last part, use the Pythagorean identity, sine squared plus cosine squared equals 1. So then we could just plug in that this is going to become 1 squared. So cosine is equal to 1, so that part becomes 1 squared. And 1 squared is just 1, so you could subtract 1 from both sides. It would then leave us with sine squared is equal to 0. And now just take the square root of both sides, and on the right side, the square root of 0 is 0. Just one more. Also, find tangent of theta. So I could use this identity, use this one. Tangent is equal to sine divided by cosine. And we got the answer for sine is 0, and the answer for cosine is 1. So that means that tangent is equal to 0 divided by 1, and a 0 divided by 1 is equal to 0. So there we have it all.